Okay. So the other webcam arrived. Woo! Not in time to be useful, but better late than never. It's 11:35. It's 11:35. So the longest increasing subsequence problem is fairly simple to state. So you have a sequence of numbers like 2, 7, 5, 1, 6, 4, 9, 8, 3, 2, 10, I don't know, 9 again, 12 or something, okay. Yeah. Yeah, okay. No, let's make it 12, just to make it fun. Okay. So, you want to find an increasing subsequence. An increasing subsequence is, can everybody hear me? Yes. I think I'm recording, yes, I'm recording both things. Okay, so for example, 1, 4, 8, 10, 12 is an increasing subsequence. Okay? So a subsequence doesn't have to be, the elements of a subsequence don't have to be consecutive, but otherwise it would be a substring. So a substring is a subsequence, not all subsequences are substrings. And we're going to want them to be, sometimes people mean, when they say increasing, they actually mean non-decreasing, which means that you can have doubles. But just to keep things simple, we're going to mean strictly increasing. So you want 1, 4 is larger, 8 is larger, 10 is larger, 12 is larger. Okay, but we want to find the longest increasing subsequence. So this is going to, and we're going to do this with dynamic programming. So it's not that bad. If you think about it from, remember I was saying that, imagine that you have this friendly, weak-willed professor who will tell you solutions to subproblems which are smaller. Okay? So how would you do this if you could ask somebody, or a professor, and you could say, well, Prof, what's the length of the longest increasing subsequence that ends within, we have to be a bit careful. Instead of just saying that that is within this prefix, we're going to say that ends here, that ends with this element. Because, because that works. So, for example, suppose that you could ask, suppose you wanted to find out what's the longest subsequence that ends. So once you know the longest subsequence that ends at each element, you can just, you can do one scan and find the longest subsequence. So suppose you want to know the longest subsequence that ends at 9. So what questions would you ask your professor? Well, you wouldn't ask what's the longest subsequence that ends at 10, because that's no help for you to figure out what's the longest subsequence that ends at 9, because 10 is bigger than 9. So you can't take a subsequence that ends at 10 and make it end at 9. But you could ask, okay, what's the longest subsequence that ends here? What's the longest subsequence that ends here? What's the longest subsequence that ends here? Here, it's no use because this isn't smaller. So here, 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 and so on, going backwards. So we're going to take that idea that you can ask for each number, you would go back and you would ask for all of the previous numbers which are smaller. So you ask what is the length of the longest subsequence that ends at each of the previous numbers which is smaller, and then you take the largest length and then you say, okay, well, for example, suppose the largest length is this one and the length is 4. I haven't worked it out. Maybe it is, maybe it isn't. But then if the longest subsequence that ends at any of these numbers which is less than 9 is here and it's length 4, then here you could say, oh well, in that case it's going to be length 5, because I would take the subsequence ending here, and I would add a 9. Yes? So, and then we're going to do that for 12, and then we're going to do that for 11, and then we're going to do that for 12. Okay? So, why does the value matter? The list is unordered. Yes. But if, for example, you ask me what's the length of the longest subsequence that ends at 10, and I tell you 6, that doesn't help you compute the length of the longest subsequence that ends with this 9. Because you can't put the 9, if you said 1, 4, 8, okay, so it's not going to be 5, it's going to be like 4 here. And then you said 10, well, you can't append a 9 to this because the 10 is too big. And you're not actually, without looking at these numbers, you're not even sure that you can replace the 10 with a 9 because maybe this has a 9 in it. And then you can't include that 9. Okay? So the subsequence is ordered, yes. The whole list is not ordered, but the subsequence is increasing. So now we turn that idea around, and instead of you asking about things at the end, you're going to not use your helpful, friendly, spineless professor. You're going to sort of do this for yourself, and starting at the beginning. So that way, you will always know, when you get to this 9, you will have worked out all of the lengths of the longest increasing subsequences that end at all of these elements. So let's start with that. The longest increasing subsequence that ends at 2 has length 1, and it is just that 2, right? That's easy. Okay, so 7, we look back through all the numbers before 7 that are less than 7, and we find the largest length, which is 1, and we add 1. So this is 2. And, okay, can you read this? Okay, good. Oh, this webcam is so cool. So we do the same thing with 5. We look back, we ignore 7 because it's bigger than 5, greater than or equal to 5, and so the only thing we can add to is this list of length 1 that ends at 2, so this is a 2, 1, we look back through all of the numbers which are less than 1, which is nothing, and then we say, okay, so the longest list is length 0, so we add 1, so this is a 1. Here, we look back through everything that's less than 6, which is everything except the 7, and we say, okay, so what's the longest length? It's this 5. It's the list that ends, increasing subsequence that ends at this 5, which has length 2. So this has length 3. For 4, we look back, we ignore the 6. The 1, so the 1 would give us a 2. The 5 we ignore. The 7 we ignore, and the 2 would give us a 2. So we have a 2. Now we look back, the 9, everything is less than 9, so we take the biggest number, which is the 3, and we add a 1, and we get 4. So before we go any further, somebody asked and said it really changes the algorithm. Where did my blue pen? Okay, so it really changes the algorithm if we're just returning the length or we're returning the whole list. But it doesn't. Because if we wanted to return the whole list, now what we could do, 2 is just that. 7, we just store a pointer to the number where we found to the largest, so the number less than 7 that had the largest length. That 9 looks like a 5. Which 9? This 9. Okay. Okay, yeah, okay, sorry. Will do. So 5 also goes here. We store a pointer to this. 1, we don't store a pointer. 6 points to 5. 4 points to either 1 or 2. 9 points to 6. Okay, so 8, what do we do? Okay, so 8, we go back through here, we ignore the 9 because it's bigger than 8. So we look at the 4, this would give us a 3, this gives us a 4, this gives us a 2, a 3, a 3, so we say, okay, the best we can do is a 4. Writing a bit bigger. Writing a bit bigger and very messy. And it also points back to the 6. Okay? So, 3, we ignore the 8, we ignore the 9, we ignore the 4, we ignore the 6. We look at the 1. The 1 would give us a 2. We ignore the 5, we ignore the 7, and the 2 would give us a 2. So we get, okay, I'm mixing up the counts, we get a 2, and it can point to the 1. Okay. 2, we go back, the only thing we can actually, that's smaller than 2 is a 1, so we get a 2, and it also points at the 1. 10, everything. So we go back, and the biggest number we find is a 4, which is either at the 9 or at the 8, so maybe we take the 8. So that's going to give us a 5 here. Remembering to write bigger. It's going to point at the 8. The 9, we ignore the 10. This would give us a 3, this would give us a 3. This would give us a 5. This would give us, we can't take this, we ignore it because we want something strictly increasing. This would give us a 3, a 4, a 2, a 3, a 3, a 2. So we take this, the 4, this gives us a 5. We store a pointer. 12. Best we can do, we go back, we look at everything, the best we can do is a 6, which is like this. 11, we go back, the best we're going to do is a 5, so that's going to give us a 6. And then at the 12, This will give us a 7. We ignore this because the 12 is equal. This will give us a 6, a 6, a 3, a 3, blah, blah, blah. We go back through all the stuff, so the best we're going to get is a 7, and it points here. Now, in this case, okay, just to make this a nicer example, I'm going to add another number. I'm going to add a 5. Because that, for the 5, we look back, these, so this is actually roughly, okay, the 5, this would give us a 3, we ignore this, this would give us a 3, we ignore this would give us a 2, this would give us a 2, so the best we can do is a 3. No, red. The black marker is running out of ink, so I'm kind of trying to, okay, so 3. This is just to highlight the fact that the biggest length, wait, what was 4? Where? 4? What is 4? What's supposed to be 4? Back at 8. This is a 4. It is a 4? Okay. Sorry. So, mixing up pen caps. So, then we scan and we say, okay, the biggest length is 7, and if we actually want the sequence, then we have it, because each thing stores a pointer to the previous number. So we say, okay, 7 goes. So the biggest number, the biggest length is 7, which is the 12. It points to the 11. The 11 points to the 9. The 9 points to the 8. The 8 points to the 6. The 6 points to the 5. And the 5 points to the 2. 1, 2, 3, 4, 5, 6, 7. Oh, magic. So we're all happy. Except we're not super happy because this is kind of slow. But let's think about, well, first of all, let's write the recurrence. So let's call this red array A. So let's call the blue array, what are we going to call the blue array? B, yeah, B. For blue, and the red array is going to be R. What a mess. Okay, B and R. So what are we going to say? We're given B as an input. Yeah, B is a good name for a blue array. So we're going to say that AI is the length of the longest increasing subsequence that ends at BI. Okay? So that's what we want. Because that way, obviously, when we're finished, we just scan A, and not A, R. Ri is the length of the longest increasing subsequence that ends at BI. So that way, if we manage to compute R, we just scan it, and if we're just returning the length, then we return the largest number in R. And if we want to return the actual sequence, then we need this array of pointers, which we will call G, and then we find the biggest number in R, and then we walk backwards following the pointers in G and return the sequence. Yes, A should be R, sorry. So, how are we going to do that? Well, we said that Ri is max over J, where J is, are we counting from 0 or counting from 1? Let's count from 0, so that this is actually going to be easier to write in C later if we want to. So J is greater than or equal to 0 and less than I, and it's going to be Rj such that Bj less than, less than Bi. So we're saying we're looking for the largest length that ends at something that is less than Bi. So we found this largest length, and then we add 1, because we can add Ri. And then we have to, we have to define this so that if this is empty, then this is 0, and then we add 1. But, that's just, you handle that case. So, this is the recurrence. So, how do we do this? Well, we just say for I equals 0 to n minus 1, for j equals 0 to I minus 1. And then we realize, oops, I should have stuck a max in there. So max equals 0 for j equals 0 to I minus 1. If bj less than bi and rj greater than max, max equals rj. Is this right? And if and for and for, so and then you write something else which scans R and returns the biggest number. Okay, everybody could do this? All of my whole 19 students. What does the if statement say? If bj is less than bi, and rj is greater than max, so you're checking and you're saying, if I want to find the maximum value between R0 and Ri minus 1, but subject to the condition that, so I'm looking for the biggest Rj, but subject to the condition that Bj is less than Bi. So yes, this should be an I. Sorry about that. Oh wait, okay, then what I should do is I run through here, and in this place, I should say, before this N4, I should say, well, actually, I don't even have to have a max. What I can do, okay, so it's time to